Sample problem. Find the solution to the system of linear equations. So in this problem, we have 4 equations in 4 unknowns. The unknowns are w, x, y, and z. In matrix form, the system of linear equations will be the 4 by 4 matrix is the coefficient matrix, followed by the 4 by 1 vector, which is the vector of unknowns, and on the right side of the equation we have the vector of constants. So in this problem, we will be solving the system using Cramer's method. So in order to do that, we have to compute first the determinant of the coefficient matrix. So for a 4 by 4 matrix, we may employ different methods to solve for that one. And in this case, we find that the determinant of the coefficient matrix is equal to 24. Next is, we will now employ the Cramer's method. So in order to do that, in order to solve for one variable, Cramer's method states that we have to compute the determinant a sub w and the determinant of the coefficient matrix, where a sub w is the same as the matrix A or the coefficient matrix, except that the kth column or the column that corresponds to the variable that you are trying to solve has been replaced by the entries of the vector of constants. So what I'm trying to illustrate is that a sub w is the same as the coefficient matrix. So as you can see, pareho lang sila sa coefficient matrix, except that we have to replace the column that corresponds to the unknown. So in this case, the first column corresponds to the column of w, and we replace that by the vector of constants. And the rest is determinant method lang. So the determinant of the numerator, or a sub w, is equal to 24, and then divided by the determinant of the original coefficient matrix, which is equal to 24, so w is equal to 1. Next, let's solve for x. So the same pa rin ang principle, except that we now have to replace the column which corresponds to the x column. Okay, so as you can see in here, we have the original coefficient matrix, and then we will be replacing that one, we will be replacing the column which corresponds to the x column, and then replace that with the vector of constants, and then solving for the determinant. So we have negative 48 over 24, which is equal to negative 1. Same goes with y, which is we have to replace the third column because that column corresponds to the y column. Replace that one with the vector of constants, and then we find that the determinant is equal to negative 24 divided by 24, that's equal to negative 2. And the same with z. So this time we will be replacing the fourth column with the vector of constants, and that's equal to 72 over 24, which is equal to 3. In summary, the unknowns w, x, y, z have the solution 1, negative 2, negative 1, and 3, and that's the final answer.